So today we're going to cover angle relationships in circles. So the first angle relationship we're going to talk about is when a tangent and a chord intersect. And that's called the tangent and intersected chord theorem. And what this one states is that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So for example, the intercepted arc for angle 2 is this arc that's highlighted in blue. Then the intercepted arc for angle 1 would be the red. So let's add some numbers to this slide just so we can see how it works. So for example, if I told you the measure of the blue arc was 250 degrees, then to find the measure of angle 2, what I could do is the measure of angle 2 is equal to 1/2 its intercepted arc there, the BCA. So 1/2 of 250 degrees gives me the measure of angle 2 to be 125. Now to find arc AB, remember in an entire circle there are 360 degrees. So I could do 360 minus the 250, and that's going to give me the measure of the red arc. And remember, angle 1 is going to be 1/2 of its intercepted arc. So 1/2 of 110, and this will tell me that the measure of angle 1 is 55. So these were just some numbers that I made up to go ahead and demonstrate this theorem. The next theorem is called angles inside the circle theorem. Now, I actually made up my own name for this one. I call this one the floating angles theorem because it sort of looks like these angles are floating inside the circle. So the name I've given it is floating angles. So when my angles look like they're floating. Notice both angles 1 and 2 here. Neither of these are a central angle because this vertex is not the center of the circle. So when you have the floating angles, it's not going to be a central angle and it's not going to be an inscribed angle. There's just going to be floating in the middle. So what I can do here is the measure of this floating angle, you're going to take its 2 arcs and you're going to add them and then multiply it by 1/2 or divide by 2. So for example, to find the measure of angle 1, which is right here, I'm going to take this intercepted arc and then the intercepted arc of the vertical angle, add them, divide by 2. Let's give this some numbers to try this in action. Let's say I want to find the measure of angle 1. I could say that this red arc is 80. I'm just making up numbers here. And let's say this one's 40. So to find the measure of angle 1, I'm going to use this formula. So I'm going to take the measure of angle 1 is equal to 1/2. DC is 80. AB is 40. I'm going to add them and divide by 2. So 1/2 times 120, and the measure of angle 1 is going to be 60. Again, remember that vertex is not at the center, so that's why the arc and the angle are not congruent. Now, to find the other angle, remember these are vertical, so this side would also be 60. However, if I wanted to find angle 2, realize that 1 and 2 together are sitting on a straight line or a straight angle. They're supplements. So if I want to find the measure of angle 2, I could just do 180 minus 60, and angle 2 is 120. So again, we're still using skills from before to to find these missing pieces. So this is angles inside the circle. They're floating on the inside. Next, we're going to see angles outside of the circle. Everybody good here? All right. Now, when we have an angle that's formed on the outside of the circle, this angle is created by three different scenarios. I either have two secants creating this angle 1. So let me go over this. This is a secant. So this is two secants that is creating this exterior angle of 1. Now, in the formula, I'm going to be talking about a big arc and a little arc. So the big arc is this intercepted arc here, which is x. Then the little arc is this side of the angle. So this is my big arc, and the blue is my little arc. Call that little. Call it lil. Okay, over here, these are two tangent lines that are forming angle 1. And again, the x is my big arc. It goes from here to here, from your point of tangencies. So this is big. And then the little is right here. That's the little arc. Then the last scenario is the angle is formed by a tangent and a secant. So this is a tangent and a secant. These were the two tangents. So again, I've got my big arc, which is x, and then I've got my little arc, which is right here. And again, that's represented by the letter y. We're going to use the same formula to find whether it's the two tangents, the two secants, or the tangent and the secant. We're still going to always use the same formula. So the measure of the outside angle, so the measure of that is equal to the big arc minus the little arc divide by 2. Now you could also, if you don't want to divide by 2, you could do big minus little times a half. Either way, this will give you the outside angle. And we're going to do some examples of these. The next one is a definition, and it's a circumscribed angle. We've seen circumscribed polygons, but now we have a circumscribed angle, and this is a circumscribed angle is an angle whose sides are tangent to a circle. So the circumscribed angle is this angle B that's here. Notice its sides are the tangents. And let's see what the circumscribed angle theorem states. So the circumscribed angle theorem states that the measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the same arc. So here is my circumscribed angle, right here, the ADB. And then you're going to take 180 and then subtract out the angle that has the same arc. and they'll give you that measure. So now let's try and do some examples for all of these theorems that we just learned. So for the first one, they're giving us that UT is tangent, and they're also giving us the measure of angle U, as well as those two arc measures. So let's go ahead and see if we can figure out where WT is. So WT is right here. I'm going to call that X when I go to put it in my formula. So little x. So here, let's see what we have. I'm going to use the formula because I can see that this is a tangent. It was given to me. And that US is a secant. So the formula I'm going to use to answer part A is going to be big arc minus little arc divide by 2 equals the outside angle, which is angle U. So my big arc is going to be the blue. That's going to be big. And that's the 100. My little arc is what I'm looking for because I have the angle measure. So my big arc is 100. My little arc, I don't know. And angle U is 30 degrees. I now need to solve for X by first getting rid of the fraction. So I'm going to multiply both sides by 2. The 2's will cancel. And now I have 100 minus X equals 60. I need to get X by itself, so I'm going to subtract 100. Negative X equals negative 40. Divide by negative 1, and X equals positive 40, which is the measure of WT. So arc WT is 40 degrees. Come back up here. The next question is asking me to find TVS. TVS is located right here. For this one, this looks like to me to be a floating angle. So I'm going to use my floating angle formula where I'm going to add the two arcs. So I'm going to add 110 plus 100 and divide by 2. And that will give me the measure of angle TVS. So 100 plus 110 divide by 2. So TVS is equal to 210 divided by 2, which is 105. So this is 105. And that one I used the floating angles. Now let's go ahead and find RVS. Well, this one's easy to find because for this one, RVS is right here. Notice it's sitting on a straight line. So all I have to do for RVS is subtract 180 minus 105, and RVS is 75 degrees. And then lastly, arc RS. RS is located right here. I can find RS several different ways. Probably though the easiest way to find it, because I already found this one to be 40 right here, is to go back and remember all arc measures or the complete circle is 360. So if I come around here and add 110 plus 40 plus 100, and then subtract from 360, that will give me RS. So for RS, I'm going to add 110, 40, and 100. I get 250. I'm going to take 360, subtract the 250, and arc RS is 110 degrees. Because that completes my 360 degrees. You could have also used the floating angles there, but I think it was a lot easier just to add it and subtract from 360. Again, when you're solving these, treat them like puzzles. Sometimes you have to find other pieces before you can find exactly what it's asking for. Pretty good on this slide? Let's try example 2. So here it's telling us that if the measure of arc AB is 105, now notice there's only 2 letters here, so that tells me that it's referring to the minor arc here. So this is 105. Notice these 2 lines here. These are 2 tangent lines. So the formula I'm going to use to find the measure of angle D is going to be big arc minus little arc, divide by 2, will give me angle D. Now, I know little, the red is little. I need to find the big arc, because I can't have so many unknowns. Put that back. So in order to find the, I did that. Okay, so then now to find the big arc, I know that there are 360 degrees in a circle. So I'm going to subtract 105, leaving me with 255 for my big arc, which goes from here all the way around here to B. So this is 255. So now I'll use the formula, 255 minus little arc, which is 105, divide that by 2. When I subtract, I get 150, divide by 2, and angle D equals 75 degrees. So for example 3, they're asking me to find the measurement of arc AB. So AB is over here. I'm going to call this X. Notice this time I have 2 secants forming the outside angle, which is angle 10. So I'm going to use the same formula. I'm going to do big minus little, divide by 2, equals the outside angle, which is 10 degrees. So I don't know my big arc, but I do know my little arc, and that's going to be 20. And it equals the outside angle, which is 10 degrees. First thing I need to do to solve for X is to get rid of the fraction. Let me multiply both sides by 2. This will cancel. X minus 20 equals 20. I need to add 20 to both sides. And X equals 40. So 40 degrees is the measure of arc AB. One last example, and then I'm going to summarize everything for you. Pretty good here? Let's try the next one. For this one, X is actually a circumscribed angle. So to solve this one, I'm going to be using the circumscribed angle theorem. So my circumscribed angle is this angle D, or the one that's x degrees. So remember, for that formula, we're going to take the circumscribed angle, which is ADB, and it's equal to 180 minus the central angle that has the same intercepted arc. So that's going to be angle ACB. So that will be this one. And then the ADB is this x. So we're going to do x is equal to 180 minus the measure of that central angle that has the same arc, and then 180 minus 35 gives me 45 degrees. And that's the value of x. Now let's do a whole little summary here of all the different angles that we've seen so far in chapter 10. Pretty good on this slide? I'm going to add a page. This is not in the notes. All right, so back at the beginning, and we took a test on this yesterday, the first type of angle we learned about was a central angle. So if I draw a circle here, if I add the center, and I draw in an angle here, this is an example of a central angle. Notice its vertex is at the center. So if I told you that this angle measure, let's say this is angle 1, if I told you that the measure of angle 1 equals 60 degrees, so this would be 60, its corresponding arc would also be 60 degrees. So let's say I put an A here and a B here. So the measure of angle 1 equals the measure of its intercepted arc. So 60 degrees for the angle, 60 degrees for its corresponding arc. So when it's a central angle, the angle measure and the arc measure are equal. Then the next type of angle we learned about was an inscribed angle. So let me draw one of those. So if I have my circle here, remember the inscribed angle has its vertex on the side of the circle. So vertex is on the side of the circle. So an example could be like this. And again, let's say this is angle 1. So if they told you that the measure of angle 1 was 20, if I put an A and a B here, then the measure of its arc is going to be double that. So it would be 40. That's when you have an inscribed angle. This was all prior to today. Today, the first thing that we learned about was when a tangent and a chord form an angle. So let's go ahead and take a look at that. Add another page. Let me draw a circle again. Let me draw a tangent. And then a chord. Let me add some letters here. So the point of tangency is B, and that's A. And let's put a little 1 here. And let's say I told you the measure of this arc is 100. So recall that the measure of angle 1 is equal to half the measure of arc AB. So angle 1 would be 1/2 of 100. So angle 1 would equal 50 degrees. This is when a tangent and a chord intersect. Tangent and chord. Now let's look at the floating angles theorem. Again, this is all a review of what we just covered today. Remember, when you have the floating angles, this is where you're going to have two chords, and they're not going to be diameters, because again, this can't be a central angle. For this one, remember, let's add in some letters, A, B, C, D. So for the floating angles, and again, this is my made-up name. Let's say this is angle 1. So to find the measure of angle 1, you're going to add arc AB plus arc CD. So it'll be AB plus CD divide by 2. So let's say arc AB was 60 and CD was 40. To find the measure of angle 1, I'm going to add 60 plus 40, divide by 2, 100 divide by 2, and angle 1 would be 50. And then the last scenario are the outside angle. So then that was where you had the 3 circles. So you have that one. And maybe I'll do it here so I don't have to, oops. So this one was formed by, let's draw 2 secants. So when 2 secants intersect and form an outside part, outside angle, that was the first picture. Then we also had the tangent and the secant. So if I draw a tangent and a secant, again, that's forming an outside angle here. And then the last one was 2 tangents. Let me draw that circle. So 2 tangents. It's like the ice cream cone. All 3 of these are going to use the same formula. They're all going to do big arc minus little arc divide by 2. And it's going to give me the outside angle. So the big arc, oops, I want to erase that. The big arc, I'm going to do in blue, and then the little arc, I'll do in green. So this would be the big arc. This would be little, 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 and then big is over here. So this is a nice little summary of everything that we've just covered up till now. So again, you know, try to get into the habit of making yourself study guides like this. Try to condense the information down, because again, what's nice this year is you've been able to use cheat sheets to take these tests. But keep in mind, when you guys go to start taking the SAT or the ACT, you're going to need to go back and memorize all of this information. because they don't give you reference sheets. They do give you area formulas and volumes, things like that, but none of the theorems. So that is it for 10.5. You do have a homework assignment due tomorrow. Again, after spring break, we're going to take a quiz on this. So when we come back from spring break, we're going to have a quiz on 10.5, 6, and 7 on that Wednesday. We will cover the 3 lessons before the break. That's it. Any questions? Anybody need me to go back to anything?